Hello everyone, this is Kiran Kumar Ane. I hope every students of F section are being safe at home. And since we are in shortage of the engineering graphics problems, I am going to solve today two problems of over the planes. Okay, and the problem statement as it is, since you are familiar with the few concepts already, so I will brief once again related to the concepts while explaining the methods involved in this particular problem. Okay, so let us look into the problem statement. We are having a plate having a shape of an isosceles triangle, has base 50 mm long and altitude 70 mm. It is so placed that in the front view it is seen as an equilateral. It is so placed that in the front view it is seen as an equilateral triangle of 50 mm sides, and one side is inclined at 45 degree to XY line. Draw its top view. Okay, so this is the actual problem statement. So as usual, so whenever the problems arises, you have to go for uh, the few concepts. Type of solid object. Okay, so the type of solid object is isosceles triangle. Okay, after that the next part is, so where we have to place, whether we have to place it on HP or whether I need to place it on VP. Okay, so this judgment you have to do by looking into the problem statement. Okay, so in order to judge this, he has not at all mentioned where it is being resting. So resting part is not given, but he has given one more hint. Okay, so what is that hint? Let us look into that. The front view is seen as equilateral triangle. Okay, so this is a hint. Okay, so the meaning is, we know that if I draw a horizontal line, so here VP and here HP present. So in the front view, where front view will fall? Front view will fall in the VP itself. Okay, in the front view, it's seen as an equilateral triangle. Okay, that's what he has said. Which is of sides 50 mm. Okay, means all the sides are 50 mm. The side dimension is 50. So this is the hint he has given. So if I place the object in the horizontal plane, okay, so this is the judgment you need to do. If I place that in the horizontal plane, then I am unable to capture the front view as a equilateral triangle. Okay, so if I place the object exactly over the VP, okay, like this is the isosceles triangle. If I rotate the another end, then it is possible to get into as a equilateral triangle. So where I should place object, I should place object in the vertical plane. Okay, this is by doing the judgment. If I place it over the HP, I am going to get the line over here. Okay, if I place object here, I get the front view as a equilateral triangle. Okay, that's why I should go for drawing the first sketch in VP. And the next one is, he has not at all provided the angle here, so I need to calculate that this angle. What is the angle? I have to calculate this part. And the next one is, and one side is inclined at 45 degree to XY line. Okay, so how will you do that? Draw its top view, he is asking. So once it is done, the next part is 45 degree to XY line, to whether I should draw here or here. So that is judged. Since the angle is taken for the VP here, and that 45 degree angle should be with respect to horizontal plane. Okay, either you can draw in this way or you can draw in this way. Okay, both way you can do the it's a front view. Okay, so that I'm going to get the top view here. So the path you are familiar right now. Maybe the different path is taken in this way. Okay. After that, the final view will be coming here. So I hope everyone are getting this. Next, let us look into the actual problem. So the first, draw the XY line. Draw the isosceles triangle. So how to draw the isosceles triangle? That's the question that you may get. So it is by taking change that one. First, you have to draw the side which is of 50 mm, and then from the midpoint you need to construct a vertical line which is of midpoint of this line, which is of this vertical line. This distance should be 70 mm. 70. Okay. So once you have drawn this, okay, it should be imaginary line. From the corners of those lines, you need to join the circle. Okay. So that it forms the isosceles triangle. So this is a method you need to follow to construct the actual model. Okay, once it is done, the next part is, this is the front view. You need to mention its dimension 50. You have to project all the points to the top view. Okay, and mention the name as A dash B dash C dash and construct the top view. Okay, here since we are weaving in this direction, so A dash is appear first, B dash next. That's why A is in visible point and B is in the bracket. Here so only C is dash is there, that's why it is C. Okay. Once it is done, then usual step that we need to follow is I have to construct a VP angle. Since VP angle is not given, instead I have to go for the actual assumption that we has provided. The front view looks like an equilateral triangle. Means I should construct the equilateral triangle here and then I need to project that downward. Okay. So I'm going to do that part. So project A dash B dash to the certain reference distance from the first part and then draw the equilateral triangle of dimension 50 mm. Once you did that, you have to do the naming, and later you have to project the vertical lines from the each corner, and since it is some, I know it's the top view has 70 mm, that is AC distance. You have to project C to the some extent and then cut the arc. Okay, by holding this as center, you have to cut the arc of dimension this much. Okay, once you cut the arc, you need to join that. Okay, so after that, do the naming. Once naming is done, the next part is, so VP angle I have taken. You need to measure this. What is the actual angle that they are going to get? Okay. Once you measure the angle, you have to go for the HP angle. HP angle is 45 degree. We know that. So draw the line of 45 degree. Either you can go for in this way, or you can go for this way. And he mentioned that one side is inclined at 45 degree line. So which is the one side? Any side you can take, but I'm going to take the resting side only. That is, which is the resting side? A dash B dash. So by take A dash B dash and take one reference point, cut the arc of that much dimension. After that, recreate the whole drawing by going through the locus. Okay, locus method. Okay, construct the actual triangle. Once you did that, next part is projection it downward. Vertical projection from A dash, horizontal projection from A dash, like this. Vertical projection from B dash, horizontal projection from B dash. Vertical projection from C dash, horizontal projection from C. So once you did that, you connect all those so that I am going to get the top view of the given uh, isosceles triangle. Okay, this is a method you need to follow. So the difference is here he has not at all mentioned what is the VP angle. Instead, he has given the front view concept. Okay, so I hope this problem everyone will exercise. And let us go to the next problem. A square plate of 50 mm sides rests on HP such that one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. Okay, so as usual, the first method you need to follow is which is the actual body that I need to draw. That is square plate. 50 mm side dimension is given. Rests on HP such that the diagonals is inclined at 30 degree to HP and 45 degree to VP. So here also we need to judge where I should place the body. So since he said that it rests on HP, the object should be in HP only. So the object should be in HP, horizontal plane. Such that, and once you consider that, whether I should place the square plate in this manner or in this manner. So you have to judge this. So which one I should pick. So that is by looking into the next problem statement. He said that one of the diagonal, okay, so one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. So this is, if I redraw this, otherwise we are going to confuse the. So I can place in this way or else in this way. So if I place in the resting one of the side, this is the corner condition. So if I do this, then I am unable to get the diagonal as some angle, okay, or 30 diagonal. I am unable to make it 30 degree to HP, diagonal 45 degree to VP. So if I place in this manner, that is corner condition, I can easily place this diagonal 30 degree to HP and 45 degree to VP. That's why I have to go for this corner condition. Okay, this is the judgment you need to do. Okay, once you did that, let us go for the next subsequent steps. Okay, draw the XY line, mention it, and do the construction of the square plate. Okay, by taking corner as your reference. Mention the dimension and do the naming notations. Once you did that, do the projection one by one and draw the front view. Okay, front view is a line. So A dash, B dash, D dash. Since if I going for this view, so B is appear first, D is next. That's why B is in B is drawn as it is. D is in the open bracket. So once you did that, the next the angle that I should consider is HP angle. Okay, HP angle is 3. So do the construction and do the naming. I hope everyone knows how you are going to construct it. Draw 30-degree line, get this distance, cut the arc, get these two distance, cut the arc. Okay, here. So once you cut the arc, two arcs, so connect them. Once you did that, you go for a vertical projection from each corner from A dash and get the horizontal projection. So A dash, A, B, C and D. The intersection of these two horizontal and vertical projection from each point gives you uh, the respective corner. Once you did that, connect all those corners. Okay, so that I am going to get the actual model in the top view. Once you did that, is I have to go for the VP angle, but here this case is a little bit different. Okay, so that is simply has provided it is 45 degree to VP. So all the previous problem that we did is related to the appears to be. Okay, so when the problem arises with the statement like if it appears to be 45 degree to VP, then the same thing I am going to construct. Okay, same sketch we have did in the previous problems, but here appears to be means the whole drawing from the second portion that I have taken as it is. Okay, that is what the actual thing. But here he has not at all mentioned it is appears to be, and in addition to that, go for the top view of the line, top view of the object. Top view is inclined. Top view is inclined at that some angle. Okay, so like that, if he mentioned, then you have to do the actual problem with the few more steps. So how to do that? First thing is you have to draw 45 degree line first. Either you can draw in this way or draw in this way. So both are correct. First you have to draw 45 degree line. Then you need to measure this distance, that is diagonal. So that diagonal measurement distance you have to cut the arc like this. Once the arc over that particular 45 degree line, the intersection of the second point, that is A here right now, okay, or simply you call it as A1, okay, for your reference, simply call it as A1, that is this distance is this one. Okay, later you have to measure this AC distance and you need to cut one more arc over that locus line. This is what we call it as a locus of A. So you need to measure this distance AC and you have to cut one more arc by taking C as fixed point. You have to cut one more arc. So this is this additional step you have to do when we don't find appears to be here. Okay, if appears to be is there, you just eliminate this portion. You do the problem as it is from the previous cases. Since appears to be is not there, I should construct this in this way. Okay, once you cut the arc, you just name it as A, and then by taking A and C as your reference, recreate these 2 points, that is D and B. Okay, these two are fixed. These two are fixed. AC is fixed. Measure the distance A to D, cut the arc, measure distance C to D, cut the arc by taking A as center, C as center. Similarly, this A as center, measure B, A to B distance, cut the arc, C to B distance, cut the arc. Okay. So like this, I have to recreate the whole thing. Then we join all those. This is what you have to do. Okay. So if you do that, then finally we come across with the actual view. This is the additional step you need to do when we don't get appears to be here. Okay. So once you did that, measure this actual angle. After that, the next question is simply do the vertical projection, horizontal projection, vertical projection, horizontal projections for all points. Once you did that, finally we come across with the intersection of these two, D to B, D to D. I get the particular points. You just connect them. So finally, this is what the front view I am going to get for the given problem. Okay, I hope everyone will solve these two cases. Okay, and the next subsequent contents I am going to upload in the next class. Thank you everyone. Stay home, stay safe.